We're late!
Hi, Eric. How are you doing?
Hello, Adam. We may have had some hashtag technical difficulties starting the show tonight, but, it happens. Hashtag problems.
My phone decided to upgrade its operating system just immediately before the show, which I was not prepared for.
I've gotten very good at saying no to the Unity dialogues that inevitably come up before every single show. Do you want to do a new version of Unity just before your show?
Generally, I want a new version of Unity, but like immediately before the show, not the best time.
Yeah. So, hello all. We are continuing on our ecosystem adventures tonight. Last time we taught our rabbits of our wolves, rabbits, and plants ecosystem simulation. We taught our rabbits how to breed and get faster, and they turned into little rocket ships.
I think we actually taught the wolves how to do that too.
Oh, did we?
Because I think we share enough code between the rabbits and the wolves that they were both taught how to evolve at the same time.
Oh, I think it was just that. Yeah, we'll have to go look at the code.
We'll have to go look, but I think we might have accidentally made super wolves at the same time.
I just remember that the time when we ran through the simulation, eventually the wolves started starving, presumably because they could not catch up with the speedy little rabbits.
That's true.
So yeah, tonight we're going to do a bit more genetics, in quotes. I don't really know what a genetic algorithm is, but maybe we're faking one.
I think it's a genetic algorithm. Like it's got a fitness function, and it
has a fitness function. I guess the wolves are a fitness function.
Survival's a fitness function.
Yeah, so I think we're going to play a little bit with genetics, and inevitably things always take longer than they should. But maybe if we really get going, we can add some sort of gaming elements to the simulation. I think it could be fun. So
that sounds great. Should we go to the code machine?
Let us go to the code machine. I have to push the buttons. Justice. The code machine. Maybe we want the Unity machine instead. So if you haven't seen it, this is what it does.
So to recap, so the green balls are some sort of vegetable like lettuce. The white balls, those are rabbits. And the blue, teal colored balls, those are the wolves, right?
Correct. We have teal wolves in this simulation.
And all the animals sort of like get darker and darker as they get hungrier. Is that what's going on?
Correct. As you run out of, life energy, you turn darker and darker as you get hungrier. Yeah. And eventually you starve. That's the only way to die in this game, is to either get eaten or starve. There's no, you cannot die of old age.
And then the speed parameter here that we're seeing changing is our average speed of the rabbits, which we sort of expect to go up over time because we think faster rabbits will be better at reproducing.
And I think we added some crazy high mutation rate at the end of last time, which may be slowing down the evolution because the rabbits are flip-flopping around the speed. But we can go look at that code. Speaking of, I have the code here. I think that was in Spawner because we decided our our architecture is a little screwy here. Yeah, here. So this is our merge traits function, which should not live here for this fix me. And we grab the evolvable, or we make a new evolvable, which is where we take our evolvable traits, and we set its gather speed equal to the average of its parents. And then you're right. Did we maybe do this? You're right. We did. Predator and prey reproduction. So we made them faster.
We were a little bit too symmetrical. I mean, maybe that's good. Maybe they should both evolve. But
well, we could actually very easily see that, right? If we change our HUD. Now I feel like I have to abstract this. This is Iterable? I don't know. C#. Here's a list. What is this?
No idea.
Return. Go to definition. It returns a.
Oh, it returns a like square bracket, which I guess is an array of some sort.
Sure. Okay, average gather speed. Oh, except this should be big A, right? Because we have power camels. And this is a animal.
Animal, vegetable, mineral. Oh, we need minerals. We're clearly missing minerals in our simulation.
Maybe the plants need to eat minerals.
Oh, maybe HAL 9000 has a suggestion if you want to.
Oh, the HAL 9000. Time to add 100 horses, 100 horse-sized ducks, and grab some popcorn.
Yeah, our 3D modeling skills are sort of stuck at sphere here.
Yeah. I actually installed Blender on a Dream, and I started through a Blender tutorial, but I never didn't actually get it all the way. Average gather speed. Okay, this is just, it's going to keep me sane here. I cannot type the code twice. It would just hurt. Okay.
There must be, I'm sure in C# these arrays have a length.
Or animal in animals.
Yeah, it looks like there's a getter on that thing called the length.
Probably in big caps.
Yeah, with a strong camel.
There you go. Yeah. You were already there. You were 10 steps ahead of me. All right. So now this is float prey. Wait, prey average gather speed. This is average. And this is going to be predator. Come on. Have I ranted yet on this podcast about mice as an input device?
It's a little bit wonky that when we count them, we get them by tag, but when we compute their gather speed, we get them by type. But
yeah, it's mostly because we're cheating and trying to get to the script object directly. But yes, it's a little wonky. Interesting to like different things that bother you versus me.
Oh, to me, it like triggers my inconsistency thought. Like, it's possible the data model could get inconsistent, and
it's all your security. There's clearly an exploit here.
Yeah. There's like a time of check to time of use. If you tag an object of the wrong type, then boom, somebody can enter the building when they're not supposed to. Or
exactly. Okay, so I see. I started editing the thing, and it eventually hit an exception. So what did I do? Oh, I changed this.
Yeah, we were missing the code bracket, but aside from that, it's awesome.
Whoa.
Oh, they're both gone.
I also put it next to plants, which is not where it should have gone. It should have gone next to predator,
but the plants are definitely not. They're not moving any faster. Although now this is a new idea for where to go with the simulation. If the plants evolve legs and they start scampering around the board, what will happen then?
Well, the thing I actually think we should do with the plants, if we get there, is give them some like spatial awareness. Like, because they randomly spawn everywhere, it doesn't encourage like a clustering behavior. Whereas you could have like spawn locations for the plants.
Oh, yeah, we talked about this, like having like a water area and like a plant area, and making it a little more differentiated.
Yeah, I think water would be huge for this simulation. So we started at what for the prey?
At 4. Do you want to turn up time? Yeah. Oh, they're going down. I'm pretty sure in the last episode it went up.
What would be encouraging them to go down?
I think our mutation rate is just so huge that.
Whoa. Oh, because we ran out of predators.
Well, yeah, we divided by 0. Thankfully, Unity didn't crash. I think our mutation rate is just way too high. Like, it's introducing way too much noise.
All right, so first I need to restore peace and justice to our display HUD. Okay. And then
you got to put in the parentheses. Put in the parentheses. You can do it.
Where's the parentheses? Oh, I see.
Yeah.
That better?
Much better. I feel at peace now.
You can breathe. All right, so mutation rate. You think this is too high?
Yeah, before we had divided by 10, which maybe was too much, but maybe we should divide by like 4 or something.
Oh, I see. This was supposed to be divided by. And so this is then making this 0.225 or whatever.
Mm-hmm.
Okay.
Half that actually, right? Like, yeah, plus or.
Oh, you're right.
Plus or minus whatever that is. Yeah.
This is one. Right. Or 0.125. Okay. Plus or minus. Okay.
Yeah, especially for the predators. If they only start at 2, and like you could take away like 0.5 each time, you could really slow them down.
This was also only their gather speed. Presumably is not like, what is it that's limiting the... It is interesting to see the predator rate is changing. Very slowly. Like, wouldn't you expect it to change faster than that?
What's the average, right? You're taking over 10 things. Like, it's only going to cause a different survival rate a little bit. Like, it's a pretty subtle effect.
And now we ran out of predators again. I wonder if we killed off the predators. I feel like this has somehow broken our predator.
Oh, interesting. Maybe the gather speed, I'm just thinking about it from the prey point of view. Maybe the gather speed only starts really mattering when there aren't very many vegetables to gather. Because when there are tons of vegetables, being slightly faster than another rabbit doesn't really help you that much.
Oh, that's right. This isn't the flee speed, which is really what would matter.
Yeah, should we try evolving a different trait? Like, I'm just interested, like, to add more.
I also wonder if it. Yeah, I mean, we should look at the total number of speeds. I wonder actually if we're. I think we're screwing things up by splitting the speeds. I think we should go back to maybe 1 speed per. Because I think it's probably a little unrealistic that they move so much faster when they're doing these different types of thing. And then secondly, I think it could weirdly bias the model because, hey, if you have a lot of food, say your gather speed was twice as fast as your flee speed or whatever, you would then, when you have a lot of food, be really hard to catch. And when you didn't, not be. Maybe that's not the right example, but...
Yeah, I think simplifying it to have 1 speed sounds good.
So if we just change this to the speed... Oh, you know what? We could use our...
F2 super renaming.
Oh, yeah. F2.
Boom. Oh, wow. You edited like a ton of files at once. That's cool.
Whoa. You did.
Oh, the HUD makes sense. That don't make sense.
Do it again. Using the power of F2. I've never really been a big IDE person. I think in my first job I used Vim or something like that, and it was Sublime.
The global identifier renaming is, to me, so nice.
Okay, so there's some other speeds here, like wander speed, reproduce speed, flee speed. Those can all go away. That might not work.
It's on the traits, right? Traits.speed.
Oh. wonder why we split them in the first place.
We were trying to balance the ecosystem, so we were trying to get a lot of knobs to turn to see how we could get the world to be.
So let's try this. This is at least a lot easier to display now that they all have the same speed all the time. Oh, fascinating.
Oh, the speed is 0? Oh, we need to initialize it to it.
Everybody's a plant.
I think it's in the editor, right? We renamed it, so we broke the editor association.
Yeah.
The F2 is not smart enough to understand Unity, I guess.
Prefabs, predator, traits, speed. Is that where it goes, or is it like an initial speed somewhere?
Oh, it was on the spawner, I think.
Oh.
Yeah, initial prey traits, initial predator traits.
Oh, man, this is confusing. Okay, yeah, this needs to be re-architected. All right, so initially we had this as like 4 and 2.
Yeah.
That seems wrong. Well, maybe. Okay.
Do you want to? I mean, we could try different things. We could try this, and then we could try reversing it. See what happens.
Okay, so we have 20 predators. I need to figure out how to limit that. Limit our float formatting. Interesting. The predators are like way better at life here. I wonder what it was limiting them so much.
Oh man, the prey. Are the prey going to come back? Oh, wait, the predators are gone.
The predators are dead now.
Oh man. So they got really.
The predators got too good.
They boomed. They ate off all the prey, and then they died off.
Yeah. That's fascinating. The predators got too good. So I wonder what was like limiting the predators in our split speed system before.
Well, now the prey have eaten out all the plants.
But we know that this system is stable because we tuned this before. The prey and plant system is stable and hangs out at the prey being at 70, 80, something like that. Because the plants are constantly regenerating.
I see.
But if the predators, I suspect it's like the reproduction speed of the predators, that the predators allow themselves to get too many predators too quickly.
Mm.
We're missing our chief ecologist here to tell us how to actually balance this model.
It's interesting to me that the prey have not evolved to be that much faster. Like they're still hovering around their starting point. I felt like when we did this last week, they very quickly got to be faster.
Mm-hmm.
I guess they're getting faster now.
I wonder, like, what competitive pressure would cause them to. There again, we also had this big mutation rate, or relatively big mutation rate.
That's true.
Like, we could also make the mutation rate be a percentage of their current speed instead of like a fixed value.
That makes sense. Like a couple percent or something instead of.
Yeah. Like we could have it be up to 1/8 or something of the current speed. That would get to like, you could max out at plus 0.5. Because remember, we're also taking a random range within that. So it's not that we're just choosing 0 or negative 0.5 or positive 0.5. We're choosing anywhere between negative 0.5 to 0.5.
It seems pretty clear like the speed is going up now.
But relatively slowly. So this would be the prey competing with each other to get who gets the food fastest?
Yeah, I think what's going on is the food here is rare. And so who is going to get it is going to be a function of how fast the prey is.
If we wanted to have separate speeds, we also could just have a multiplier on the, like we could say that, gather speed is 1.25 of speed. Right? So we have a single trait that we're evolving. Well, the prey speed has come down again, suggesting to me this like doesn't matter.
I feel like I want to do like data analytics. Like I wanted to like dump out a ton of data and I want to throw it into like Excel and like graph it and see, because it's so hard to like mentally look at the numbers and think about them. Whereas
Well, we still don't have graphing technology. Okay, so what's next?
I feel like, should we try to balance the ecosystem again? Like I feel like it's sad that the predators die off.
All right, and the problem that we were noticing was the predators boom too hard.
What if you set the initial predators to much lower? Like,
we can turn up their reproduction cooldown.
Okay.
Or turn down their reproduction site. Like I seem to remember. Like I think that makes some sense that predator species tend to reproduce slower than prey species. But I say that with no ecological degree behind.
I feel like we're back to sort of somewhat blindly turning knobs, but sure, let's try this knob, see what it does.
We also had one run, right, that we were looking at.
Mm-hmm.
I also might want to have it display how long the simulation has been running for simulation time, because it's really hard to tell when we turn it up. Interesting. The predators are still very efficient.
Yeah, so maybe we need to add a multiplier to the flee speed.
What did it say?
Oh, but the predators are now, there's only one of them.
Mm-hmm. Why is that? We have a smite button, but we don't have a like restart the simulation button. Didn't we? I just don't remember what all our buttons do.
Yeah, we had a smite button. I don't think we had a restart button. Yeah, like the prey is not getting extinct. The predators are just not.
They're not able to catch them. Look at that.
Yeah. Can we look at the old speeds that we had? Like that might give us, like the main thing we changed was the speeds, right? So we may.
We can try. The question is whether it has decided that it. Yeah, here we go. So the predators used to have 2, 2, 10. They were little rockets when they were in the mood.
And what about the prey?
And the prey. I don't know why the prey have not saved. Never understand. Like I think Unity is like holding on to the values or something.
Oh, until you load it into the inspector or something.
Yeah. I don't understand why this one saved and the other one didn't. See, that doesn't help us any. Oh, I see. Maybe it was that I changed, right? So like if I change this to 11 or something and save, that'll probably stimulate it to rewrite itself. Yes, I bet that did it right there. So now if we look at prefab, we can see that it was 4, 2, 3.
I see. So maybe when the prey was wandering was mainly when the predators would be able to catch up to it.
Well, but it should have fled.
So if there's a fleet of 4 and the predator only has a gather of 2, how does the predator ever find the...
I don't know. Maybe the prey were just so abundant they would... I mean, the flee behavior isn't very good. It'll constantly flee from the current one. So if 2 predators are ever going at the same prey, the prey's dead. Like it's just going to keep bouncing back and forth from whichever one it's closest to. Panicking.
Can we try an experiment? Can we try just multiplying the speed by 10 for flee?
For flee? By 10?
Yeah, like in the code, like when we're interested in using the flee speed, if we just multiply the speed by 10, I'm just curious what effect that would have.
All right, so I turned this back down
to match what I was before.
Respect where it was, because that didn't seem to fix our problem. So you want to go look at our update flea. Do flea update this thing. Yes.
Yeah, that's right.
You want like float flea speed equal to traits. That's speed times 10.
Mhm.
And you would expect this to make it so the predators just starve.
I have no idea. I don't have a really strong hypothesis for what this will do. Well, you can sort of tell when they're fleeing, so that's interesting.
You can tell what they're fleeing.
It is like, get out of town.
What?
We've had enough of this. Book it.
Let me put on my jet boots.
I wonder if it's going to cause them to starve because they'll run away so far off the map that they then will have trouble going
they're
back.
not even going to be able to like wander back. You're causing this interesting behavior where like the predators are now accidentally guarding the food. I think it is causing them to starve. We have found balance.
Can you crank the simulation speed?
Oh yeah. Then we can see real rockets here. So the predators can't eat, the prey can't eat.
Okay, so that was a disaster.
I mean, we could, instead of doing 10, we could do whatever it was before, like 1.5. But I don't know that we need to keep the... I don't know that we need to like encourage them to be further, to go away more, right? What are you thinking?
I feel like we're sort of lost in... we don't have our expert to help us balance our ecosystem anymore.
Well, we may need to bring back our expert. Maybe we should do something else. Or we just lost, like, can we proceed with an unbalanced ecosystem?
I think we can proceed. Like we could pursue one of the other topics that we talked about for the second half of this episode.
Okay.
Like you talked about like gamifying it. Like what did you have in mind?
Yeah, like I was thinking, like you could imagine building a game where you, your job is to like see if you can. Okay, so let me set the stage. I enjoyed playing for a little while this sort of programming game called 7 Billion Humans, where your job is to like write a program and then execute it, and the writing and the executing are like separate, and you can debug while it's going. And I guess that's sort of like normal programming. But you could imagine this idea where you have this like holding chamber where you get to select from a menu some like set of rabbits, and you can like breed them for some period of time, and then you like seed your ecosystem with those rabbits, and like if they survive past a certain time, then you win the simulation. You go on to the next one, kind of thing.
Yeah, so maybe riffing on that idea, what if instead of rabbits you could release wolves? So as we have a situation where all the wolves die out, then if we had a way of releasing wolves with different characteristics, that might be fun.
Yes. This also reminded me that one of the things we saw last time, which we've lost somehow, is that the rabbits seem to go to infinite speed. And there was no cost to being infinite speed. So one of the things we brainstormed about adding this time was a little bit of cost. Like that your metabolism should be relative to your speed, which should now be very easy to do now that we have a single speed.
Oh, okay. Do you want to do that first? So that seems fairly straightforward to do.
So I think we have to develop a hypothesis of like, what are we going to see this do? So is it like I agree it's very straightforward to do. But like the metabolism needs to be like a metabolism multiplier now?
Yeah, what do we just multiply by the speed here?
So like effective.
Or just like, food consumed.
I see. Oh, interesting. That makes sense. The problem with this, though, is that we don't currently have a simulation where this should show up, right? Like this would be an answer to this would be an answer to like the population all turning into rocket rabbits, which we don't currently see.
Okay, I mean, we could focus on trying to create that scenario and then using this to see that scenario reach balance.
Yeah, I think we should do that first. So I think we can just do. Okay, so
why don't we take the predators out of the equation if we just want to focus on the rabbits?
Okay, sure. That's easy to do. We can just go to here, initial predators, 0. Okay.
And can you turn down the initial plants? Like, I think we go through this phase where the plants are abundant, which is pretty far. Like, this will get us closer to the equilibrium.
Turn down the plants?
Yeah.
Have them?
I go by factors of 10. Like, you're so timid. You only go by factors of 2.
I see. You're right. That may still actually be too many plants because I think it like stabilizes at like 6 or something.
You can even set it to 0, right? They'll just spawn up from nothing.
Oh, it's true. It will immediately hit the spawn rate. Right? There's actually, you're right. There's actually 0 reason for us to have any initial food density. So you're thinking that the rabbits should still evolve.
I'm thinking that turning down this food will put pressure on the rabbits to compete for the food right from the beginning.
Mm-hmm. So we're not seeing that.
That's true.
Which makes me wonder if but why not?
And we can turn up the mutation rate again. Like, it's possible that our adjustments are so small that they're sort of too subtle that it take a long time for them to see effects.
We're also like way into code down here, and we should be. All right, so like this mutation rate. So like we're currently at 1/4.
Mm-hmm.
Something like that.
I don't know if 1 divided by 2 will actually give you 0, if those are like integers or not.
I don't know. I can't see sharp to save my life here.
The other thing we talked about was using it as a multiple of the current value as opposed to a constant.
Mm-hmm. Yeah, I think that's sort of where I was. Or really, what that is not it's not mutation rate so much as like max mutation.
Mm-hmm.
We're still not seeing a change.
Can you? Is this as fast as you can make the simulation go?
There's a limit where I can fix this in the code, but there's a limit like within the editor you can only take it at 100 times or something.
I see.
But we could trivially fix that if we needed to like go to max. Like we could make the plus minus go to like normal versus max or something. But here we are just sort of bouncing around 4 again, as though this just like doesn't matter. They're also like, they continue to wander off. Oh, you know what?
Oh, maybe the wander speed is
because
like bad.
the wandering is random, and the wandering fast is a disability.
I see.
So we could. I'm not sure they're at the like perfect speed yet, but that's probably not.
Well, why don't we try the hypothesis by setting the wander speed to 0?
Yeah, these all need to end up as like multipliers somewhere.
Wanderingness. What is wanderingness? That's funny.
I'm trying to remember what wanderingness is. Oh, yeah, this was me trying to hack around how often you can change your mind when you're wandering. I'm sure this is like not the right hack, and this was now some weeks ago on vacation.
We just set the target location to our own location, so then that will cause us to not wander anywhere.
Like it was like maximally replanning, but yeah, we just. Oh, I see. What's it? We're gonna like keep planning our wandering, but that's fine. Oh, I counted out, didn't I? We'll try that. Wandering should no longer be a disability.
They clearly seem to stand still, so that it did something.
Interestingly, they're still not getting faster.
You say that, but they're already at 4.1, 4.2.
Okay. Okay. So wanderingness was a disability, or like wandering at high speeds in random directions.
If you have too much wanderlust, you might not find your cabbage.
I mean, this gets back to they really need to have some concept of like pathable locations. We also talked about that, like an episode we could do is writing our own nav mesh, because I looked into using Unity's nav mesh and I didn't understand how to implement flee behavior and respect a nav mesh, because you weren't able to like pull the nav mesh out of the Unity nav mesh objects. So you're right.
Well, this is interesting because it sort of looked at the thing that we wanted to look at with the metabolism, which is it made a trade-off for increasing your speed, and we see that it has a big effect on how the speed evolves over time.
Yeah, it was a trade-off that we didn't fully understand.
Well, I think that's a good thing about a simulation. If it tells you something you didn't understand beforehand, like it was interesting.
It makes me wonder if we half the wandering cost, like if we made the wander speed like half of the speed, would it still allow it to evolve?
Let's try it. It sounds interesting.
Or we could make the wandering speed. Yeah. All right. So like float wander speed multiplier, which this really needs to be a constant somewhere. Float you can imagine actually grabbing that off of.
I'm just amused by multiplying the location by the color and like all manner of insanity occurring.
I don't know that. I don't think Dart's autocomplete checks for types, but like that feels like a thing that it could do.
It really does, because like it may be difficult to figure out like what type of thing could go here, but like auto-completing color there, it's clearly not helpful.
Well, it just shouldn't be the first autocomplete. I actually
well, C comes before S.
Yeah, I mean maybe that's being like too smart.
I don't know. Like there's also like nearest identifier. Like, where is the wander speed declared? One line above. There's probably a good chance that's the one that I want.
Dart's autocomplete is smart in that it uses a little bit of like ML over like public source bases to like know which things you might be wanting to autocomplete. There's also some like startups that do that too. Kite.com or something is one. But
I bet a tiny bit of that will make a huge difference to how usable these systems are.
Exactly. It was like one engineer for like a month, and then it just like took us months to ship the thing. But like the actual code took very little time, and we built it first for like Google's giant internal repository, which we could do much more analysis on than like public code. But and it works so well that like that's now the way that it works. But I'm so used to Dart's autocomplete being smart that it feels jarring to go to IntelliSense, which when I said this to one of the engineers, they were like, what do you mean IntelliSense? They're like, Dart's is better than IntelliSense. IntelliSense is the gold standard. But I don't know that it's the gold standard in 2020 anymore.
Well, to me, that's part of the reason of trying all these different frameworks and languages and doing all these projects, because it exposes you to different ideas.
Yes.
When you go back to the main thing you're working on, you're like, oh, there's this weird like thing that I didn't notice was annoying, but now that I've done it a different way, I see that.
Yeah, it's just so stimulating. I've been watching, or over vacation, I watched a bunch of talks on like game dev, and it was just, I came back with so many ideas. Okay, so what did we actually do? Oh, we now know how to wander, but we wander at half the speed?
That's right.
Do you believe that it's doing that? It's not clear to me that it's doing that. I guess it looks zippier when it's going to food.
Yeah, so the speed is going up. I have no idea if it's going up slower than it was going up before. Oh yeah, I bet in the regime where the food is abundant, then speed was probably a net negative, right? Because you didn't need speed to go find food when you need it, but if you wandered too far away, then you might not find it. Because early on we saw that the speed dipped down, like below 4.
Mm-hmm. So interesting that this appears to be, well, I'm not actually sure it's stabilizing. I just don't know how far it's going to go. I think we may need to add a little max button to like throw the simulation to max. Because I don't wonder. Go ahead, sorry.
I was just wondering whether the like stable number of prey is a function of their speed.
Oh.
Like you can imagine if it was super fast, maybe you could support fewer.
Shouldn't though. Oh well, maybe actually. You're right, because they then consume the food. Oh no, we haven't done the metabolism yet. But it will once there's a cost, there's a metabolism cost to the speed.
I totally want to somehow do data analytics on all this data that we're generating, because I think there are all these fascinating questions that you could try to do. I don't know how to do that, but
well, this is all just C#, right? Now they're all mono behaviors or whatever, so we'd have to like abstract out the stuff, but that should be relatively straightforward to do. Oh, actually, never mind, because we still have to like simulate them in this 3D world. I'm sure we could like build a command line interface to this. Just be some work.
So we try the metabolism thing to see if that.
Yeah. So what did we conclude from this? So like,
my conclusion is that with the wander speed at half, increasing your speed is an advantage, and so it goes up. Although I wonder if it's maxed out. Like
it seems like it. Now, why 5.5 would be the like magic number of the wander speed? It may still be going up. Why would that be?
I mean, maybe. Oh well, it still looks like it's going up.
This is also, it's again sort of slightly bad data, because these like they wouldn't move this far away from food if we. I guess you could imagine that this is just the square is just like the food spawn area,
mm-hmm.
Or like this is the like the forageable patch, and so they don't ever want to go too far away from that. Especially since they have no memory as to how to get back to it. Okay, so shall we try metabolism?
Yes, let's try it. Oh wait, can you turn on the circles while we're here before we end the simulation?
Oh, I smited. That's the wrong one.
Don't worry, they'll
come back. Let's see. Keyboard. This one. P.
Because I can imagine you were infinitely fast, right? And you would wander so far away that you wouldn't be able to see your food anymore.
Oh. Sure.
How
It makes
close-
you wonder if the sight radius needs to be a function of the speed too.
I mean, I don't know. Like, it's kind of interesting if it's not.
Yeah. Whoa! Did I turn them off? Oh,
Maybe
okay.
it
So
only
really some.
maybe it only affects the ones that exist at that time, and we're seeing the population turnover.
Well, I think we didn't. I think in our new reproduction thing, this is weird. There's a bug that we introduced somehow in our new breeding. Why is there population turnover? Like, why are any of these ever dying?
Well, if they reproduce, then there'll be too many, and then there won't be enough food to support them, and some of them will die.
But you would still think that some of them.
I mean, stochastically, eventually it'll go to zero, right? There's like each one has some chance
Because
of.
they all just eventually like wander away and die. Like that is the cause of death, is to like wander too far from the food.
Well, they're always making new rabbits, right? And the amount of food that's being produced can only support whatever it is, 60 of them. And so eventually your number will come up, and you'll be the unlucky one who doesn't get food enough.
Okay. Yeah.
That was interesting, actually, to see the population turnover. Like, I wonder.
They're just a feature.
Yeah, I kind of want to know like the average age of the rabbits, like the
Totally.
record when they're born, and there's so much data you could pull out of this thing. It's so fascinating.
Okay, so what should we do in our last 9 minutes here? Should we turn on our?
Yeah, let's follow through on the metabolism thing. I feel like we wrote the code for it. We should follow through on it.
We wrote our one line of code.
I mean, it just makes it less pie in the sky than, oh, let's dump out data and look at it in Excel. That's very pie in the sky.
So this should now make it to have a higher cost to speed. And given that this is the initial multiplier, I actually suspect this will cause them to slow down sufficiently. Like,
well, what number are we actually using? I'm just curious.
We're just multiplying the metabolism times speed.
Yeah,
so now we're going to die 4 times quicker.
What numerical value does metabolism have?
Oh, it's very small.
Oh, I see. You're saying it is 4 times faster because initially it was 1.
Metabolism for this is 0.05. So it's now 0.2. Mm-hmm. So it's just every step is going to cost them more. I don't know where it's going to stabilize, but my sense is that they're just all going to die. They can't even make it to their food. Oh,
they're so hungry.
Okay. They can't find each other. It's so costly. So, I mean, we could easily correct this by just simply dropping the metabolism.
We could just set it so the initial value is the same.
Exactly.
Although they may like start moving their speed down, like because food is super abundant, right? So they may want to just drop down their metabolism.
This is fascinating. Like these ones appeared, but
So they didn't totally die out.
I really expect the speed to drop. Why is it going up? Like, why is speed evolutionarily advantageous? Not clear that it is. Oh, there we go.
I wonder if it's in order to find the mate. Like, clearly finding food is not a problem.
As the green wave.
Yeah, the food is doing really well in this universe.
Well, it's interesting actually that they.
It's very spatial.
Yeah.
Because I think they have to be near each other in order to, like, reproduce and survive.
And they have no flocking behavior, which is another thing that Dr. Sandell suggested. Oh, they're goners.
Yeah, they went down to 2.
Sorry, you're lonely now. Huh. So I think that was a little too extreme. So we can easily fix that by just dividing this by 4, right? So what is this then?
Why don't you put it to 0.1 just to keep our numbers round? That's dividing it by 5, which is, or you could do 0.2 or whatever. Like I don't know, but
Sure. You're not going to make me write 5/5 on stream.
Is that one of those like non-terminating fractions?
All right, so the metabolism should have a big effect, and we actually reduced the effect significantly. I still would expect this to make them want to be slower. I wonder if we should turn the wander speed off, though.
Well, there's some equilibrium value. We just don't know what the equilibrium value is.
Well, yeah.
It's clearly not going to the sky like it used to.
Wandering is such a big cost because wandering is like wasting energy if you're a rabbit, right? You're just going off in a terrible direction most of the time. You're going further away from mates. You're going further away from food in a random.
I wonder if instead of wandering, we should flock.
Exactly.
Yeah.
You want to flock, or you want more spatial awareness somehow.
Yeah, I think if you just want to wander, why not just pick a friend and walk towards them? Or I don't know what kind of flocking you want to do. But.
Oh, fascinating! I hadn't even thought about that. I mean, we could implement like the Boyd's algorithm. I've done that once.
That's probably more than 9 minutes, but maybe that's a good thing for next episode.
Yeah, we're not gonna do that now. I mean, I think we're basically done with the episode here. I was still expecting the speed to tank more.
Well, just throw in a factor of 2. Like go make it 0.2 instead of 0.1.
Oh, you mean Taslim? I also would kind of like to turn off wandering because I feel like that.
Oh, go for it. Turn it off.
Wander speed. I think
0.
This is actually the. Let's try that. They just shudder in place. Wonder if they still have a metabolic cost while they're wandering? I guess, yeah, but they don't. It's not doubled by having to come back to wherever they are. So the hypothesis is that this should make them slower. Oh. Another boom bust cycle. I do feel like we could spend some time just giving ourselves a few more tools and then bring back an expert. So it's so hard for me to imagine that we've chosen the right speed.
It is going down. Look, it's at 3.5. I think what's happening is you have to get, when you're going through the boom bust cycles before that sort of stabilized, though at different regimes of food plentifulness and the pressure on the speed is different. And so I think you have to get into a fairly stable equilibrium before there's a directed pressure on the speed. Because I think we're there now. I think 20 or 15 to 20 prey seems to be fairly stable here. And now the speed is getting driven down.
Yeah. This also goes back to the locality, because we've made ourselves as having this migratory species where they'll eat up one area and then they really have to spend a whole bunch of energy to get over to this other side of the map.
Mm-hmm.
But you're right, it is driving it down.
Yeah, so 2.8. They all died out. They got really slow and they died. But
Huh.
Yeah, there's this funny like cliff in the evolution, right? Like you can be getting better and better and better until you hit some critical point where you can't reproduce anymore, and then you just die off.
I think our real problem here is wandering, because I think that lack of a plan in wandering just really hurts you. You're just burning energy to either sit there, which is probably not the right thing, because you just ate whatever piece of food was right next to you, and now you're just sitting next to empty food.
Yeah, I'm totally in for flocking, like replacing wandering with flocking. Like I think that'd be a great thing to do next episode.
So,
Cool.
well, any final thoughts for our viewers?
I feel like the simulation has enough richness to it that it's doing things that I don't expect, and it's sort of fun to tweak it and then try to understand what's going on and then repeat that process. I found that very enjoyable in this episode.
Yeah, I wonder how much more we can put like controls in the. Like, imagine if this was a game and you weren't like running it in Unity. Like, if we could put more dials into the game, so we don't have to like go back to the code.
Oh yeah, totally. If there were like dials that you could adjust like in the UI, then the game could be like balance your ecosystem, design your perfect predator. Like,
Whoa, and that actually could, I think, be fun.
yeah, just the same fun that we're having like tweaking it in code. We could make that the game. Like that'd be awesome.
Yeah. Yeah, there's this whole like game of how the heck do you balance this thing?
Mm-hmm.
Whoa. Yeah, you could now. I'm totally. My brain is going on the like. Okay, you add constraints, right? So you can like a level constraint or whatever is the idea that like, okay, this is your fixed wander speed or your fixed metabolism or whatever. Okay, now balance.
Achievement unlocked. You can now have wolves.
Yeah. Okay, now balance again. Huh. Okay. Anyways, wonderful as always to see you, Dr. Barth.
We talked about off air changing the showtime to 7:30.
Yes.
Is that something we want to follow through on?
I think we should. So part of my New Year's resolution, if that's the right idea, is to go to bed really quite early. So this is like already past my bedtime. So we're gonna go ahead and bump back our start time by a half an hour. So going forward, we're gonna start the show at 7:30 next week. I'll make sure this is visible on Twitter, etc. So since I haven't shown any banners this time, well, we can show this one. But this one,
classic.
Send us feedback, as always. Otherwise, we will see you next week at 7:30, our brand new time, for some more ecosystem fun.
See you next week.
See ya. Take care.